With the adoption of containers, there is a rise in the need of private registries where you can push and pull the images. With the rise in supply chain security, there is need of private registry where you can push and pull the images and verify the signatures. With the rise in adoption and with the increase in the number of rate limiting for certain registries, there has been a need for maintaining a local mirror registry from all different set of other registries. So how can we achieve this? I think in this video, I have a good solution for you, which is a CNCF project as well called Zot. So welcome to Cube Simplify. My name is Sayam Pathak. And in this video, we'll be discussing all about Zot, including the demo, end-to-end, how to set it up and push and pull the images. Before starting, this video is brought to you by Cisco, Commodore, Sysdig, SlimAI. A huge thanks to all the org members who actually helps me in creating these set of videos and bringing value to you all. So make sure to check them out. Links are in the description. Now let's get started with Zot. Now, Zot is OCI native container artifact registry, image registry for use. Basically, an image registry is nothing but a place where you can place your OCI artifacts and you can pull those. So think of as Docker registry, but this Zot is completely OCI compliant, which is vendor neutral, and it doesn't even allow Docker. So the regular flow, how it works with any of the registry is there is a developer. A developer will be writing the code, and then they'll be building the code. You might be familiar with some of the building tools like Docker or Co and stuff like that. But for Zot, obviously the recommendation because of their strong pairing, so you can pair up Zot with Stacker. So Stacker is another OCI native image builder. So everything is becoming OCI native. What is this OCI? OCI is Open Container Initiative. So it is a standard which is being followed for building the image Stacker and pushing the image to Zot. And while pushing the image also, you can actually sign it using cosign and verify it using cosign. They also support notation. And then you can deploy it on your Kubernetes cluster by pulling that same image from the Zot registry, which is there. So when you push the image to Zot, it is stored as the OCI layouts. So in short, Zot is a place where you will be storing all your OCI artifacts and you can use that in your deployments inside Kubernetes clusters. And you can use for building the image tools like Stacker, and there are other ecosystem tools like Scopio, Crane, Ores, with which Zot is compatible. We'll set up the registry from scratch and we'll also do a couple of push and pull of the images so that it makes more clear how it can work. But the main purpose here is to understand what Zot is, what it offers, why it is that much useful in this new era of private registries or registries at edge, and how you can use it to push and pull the images. So coming to some of the features, yes, Zot is completely compliant to the OCI standards. So the HTTP APIs, the storage APIs, everything is OCI compliant. It is a single binary, not only a single binary, it is also a small binary. So it's a single binary model, and I have been loving single binaries model just like K3s. So it's a single binary with all the features that is included inside that same environment. And not only that, it has features versus security. What does that mean is there is a concept of extensions that we'll be going through, but you can have Zot as a minimal so that you can be compliant with security and enable a couple of extensions if you need to build your security posture, or you can have it as a full build where you will be having the full extensions that obviously adds more features as we'll discuss later on. Batteries included, it has all the fancy features like the auth, the UI, all those stuff which is there, and then unprivileged runtime process. So Zot doesn't require any root privileges, and the recommended approach is to create separate user group for the Zot process itself. And it is multi-platform as well. Again, extending on those set of features like why Zot, obviously it was created by Cisco initially as an internal project when the OCI specs and the standards were being written in around 2019 time frame. And that's where they decided to purely go for the OCI artifacts. And that's where they created this very lightweight single binary, built-in authentication, inline garbage collection, storage deduplication, pure OCI standards, supply chain security using cosine and notation, not requiring of the root privileges, binaries for multiple operating systems, TLS support, vulnerability scanning, compatibility with the ecosystem tools like Scopio and Cryo, I just mentioned before as well. And the extensions, most commonly used extensions, which are somewhat missing in the OCI standards. So those are also provided as the extensions, which we'll be discussing after the architecture. So coming to the architecture, yes, everything is OCI compliant. So all the APIs conforms to the OCI distribution spec. The storage layouts follows the OCI image specification. So you can say that I was telling you about two models which are there. One is the minimum and one is the full model. So config and auth layer is common for both the models. And in this, you will be having your image. So basically a developer, they are writing the code, they are building it into an OCI artifact. And once they have the OCI artifact, that can be stored either locally or in the S3 when it is pushed, because the Zot backend can be changed to the S3 asset. And we'll actually do that in the demo. For the metadata, you can either use again local or DynamoDB. Everything is configurable in the config section, and they have most of the configs available in the config examples on the GitHub repository. And then when it comes to the full access, it includes all the extensions which are there. Coming to the extensions obviously in any stuff means extending the current functionality, and you can actually build your own extension. So there is a whole developer guide on building the extensions as well. Current extensions are very common one, obviously, is sync. So sync is most used one because of the rate limiting stuff that we have been seeing in the past, and also to have a local copy of the registry which is there so that you can pull and push without any rate limiting over there. So you can have a mirror of as many as registries that you want: Docker Hub, OCI registry, GCR, and even Zot registry. So you can have all those, and a client can interact only with this registry, and this registry can have multiple registry with a specific, like, do they want on demand? Like, let's say I pull a BusyBox image. So when I pull BusyBox image, it should pull that from the repository, or it should be a periodic fetch that always it remains in this particular registry, and I will be able to immediately access that. Coming to the next extension, it is the search extension. So search is basically the GraphQL endpoint, and it helps you to search based on CVEs, to search based on image name, to search based on tag, to search based on if it is used by any of the other images. So multiple level of searches can be found when you deploy Zot with the search extension enabled. Lint is for enforcing the policies. Again, coming back to that security posture and the security angle that has been in the roots of Zot. So I think the extensions here is lint, and you can see in the example itself, like it's from the GitHub repository. Enable is true, and here it says mandatory annotation. So basically, if these set of annotations out of this is not there, the push will fail. So you can have compliant policies based on your company requirements, and that you can implement that, and all the images has to follow those compliance policies before they are pushing the images to your Zot registry endpoint. Scrub, basically to verify the image content proactively and detect the errors. Metrics is pretty clear, like you can get the latencies, throughput. It's a Prometheus extension, so it will integrate with your current Prometheus setup. So very fancy dashboards you'll be able to create using Grafana. UI in 2.0.0, obviously there is a new release, that RC release, that we'll be trying out today, but 2.0.0 is where Zot is moving towards. So that was pretty much it about Zot. Like, what on a whole it is simply a artifact registry, nothing very fancy to understand, a very simple GitHub repository. I can actually show you that. So this is project Zot. These are its Helm charts. So you can see a Zot, a vendor neutral production ready OCI native container image registry, purely based on the OCI distribution. And you can see that everything is there. It's a CNCF project. And in the tags, you can see the release, RC release of 2.0.0. So it's a very neat project, I would say. And this is where the examples I was telling about. So examples have all the configurations like all remote, anonymous authorization, benchmarks, bolt DB1, conform as CVE, DynamoDB example, LDAP example, metrics example. So if I go to metrics, it will say where I have to enable that extension and where is the Prometheus path, so that it will know and we'll be able to get those metrics and create the dashboards. Now what we'll do is we'll do an end-to-end demo where we'll set up the Zot registry from end to end with all the fancy features like the S3 backend, HTTPS from scratch on a Kubernetes cluster. So let's do this. And all the steps I'll put in a gist and even the values.yaml file, which is the configuration, so that you can try on your own. So I already have a Kubernetes cluster for which I have downloaded the kubeconfig file. So if I do kubectl get nodes, I'll be able to see a 3-node cluster which is ready. And I do not have anything fancy running on this particular cluster as of now. So we'll do everything from scratch. So first step is to have Nginx ingress controller installed and the cert manager. So this is the command to install cert manager. It will take some time and install all the CRDs and deployments for cert manager. So cert manager is installed. Now let's install Nginx ingress controller. So the Nginx ingress controller is getting installed. Let's do kubectl pods in all namespaces. And we can see that cert manager is already up and running and Nginx ingress controller pods are some are running and some are in container creating state, which will be ready in a couple of seconds. Now we are ready to install Zot. But before that, let's try to understand, because we'll be customizing Zot with respect to the values. I already have a values.yaml file. So first of all, I have put image with the tag as 2.0.0 RC6 because I want to use this particular image tag version to show the latest stuff which is there. On the service, you can specify the type and the port. Ingress, you can specify if it's enabled or not. And then we can specify the cert manager cluster issuer, which we have to create. So let's encrypt production is the cluster issuer that I will be creating just now before we apply Zot over here. And then class name is Nginx, implementation specific. This we have to change as per the new cluster. So let me just get the name of this particular load balancer DNS, which is the Nginx ingress controller load balancer DNS. You can see that here also. So in the load balancer section, I'll be copying this. Same here for the TLS section. This is the name, mount config. So this is the real editing that we are doing for the config. So we want authentication to be enabled. In the HTTP password, we have given the secret ST password. For the log level, we want debug. For the extensions, we have enabled the search extension. We have enabled the UI extension. We have enabled the management extensions. On the storage side, we have done the deduplication as false. We have done root directory. Storage driver, pretty interesting because we want remote storage. So here we have specified that we need S3 storage. Now for this particular S3 storage, we have region as LON1 and region endpoint. So that will be dependent on the object store that you are using. Bucket name, security, skip verify access key and secret key. Do not worry. After the video, I'll be deleting this bucket so you won't be able to access it with my credentials that you are seeing on the screen. Again, mount secret is true. Secret files is what we mounted above, and we have given admin and user, and we have to also provide base64 encoded or header. That's pretty much it for the values.yaml file that we have over here. Now let's create the let's encrypt production cluster issuer on this particular cluster before we actually install Zot. So this is the cluster issuer. Let's encrypt production and private secret key reference, all that stuff, ingress class, which is there with the email. And I'll just do kubectl apply -f ci.yaml. The cluster issuer is created. Now we'll do the Helm install of Zot project. And all the other steps can be seen here. So if we go here and we go to the installation, you can see all the Helm repo add, what all you have to add, Helm repo search, so that you can search for the version. And then you'll be able to do the install for that. So it's pretty simple. Helm install Zot project with the -f values.yaml file. It is using my current kube config, which is set, and it will install Zot in a moment. So it is deployed. Let's do kubectl get pods. Now the Zot pod is coming up. If it goes to crash loop backoff means there is some error in your values.yaml file in the configuration that you have provided. If the readiness and the liveness check will pass, it will be in running state in just a moment. So you can see Zot pod is up and running. We can also see get ingress. So our ingress should automatically be created as well. We can also see certificate, and we can see the certificate is true as well, which means our TLS stuff should work, and it should be a HTTPS Zot, which is up and running. For super secret password admin and admin. And here you go. Now, since I already have pushed and pulled the images, so it is showing some of the images from the S3 bucket that I have. So that also shows that I will be having a remote store. So even if my cluster goes away, I can set up a new registry and just point to the S3 bucket, which is there, and I will be having everything up and running. I think it's pretty neat, pretty decent. And this is the search, which is there. And I can do enter for the advanced search. And you can see I can search, sort based on different stuff, signed images, additional set of filters. So I think the search is pretty strong over here. Now let's go to the push and pull image content. So as I mentioned, it supports multiple clients, which is there like Scorpio, Crane, Auras, Helm, and stuff like that. So what we'll try to do is we'll try to use Scorpio over here to perform the OCI operations. For this particular image, I'll be using one of my images on Docker Hub, which is there, which is Sayyam911 Wasm BLR. Let's try to kind of push this particular image. And here we'll be giving the address. So that's how this command will look like. The Scorpio multi-arc, giving my image, the destination address that we just gave, and the image name that we want to give. So it has failed here because I haven't provided any authentication. Now let's try to run this again with authentication. So we'll give the username and password. And let's try it again. And this time it got connected to our Zot instance, and it is copying the blob over there. Now let's go back to our Zot instance, refresh it. We should be able to see Siam image that has come over here. So the architecture information is also showed over here. And if we go, we can also see the layers. We can see the details. We can see uses and the used by that I was telling you, and the vulnerability scans if that is enabled, the size and the metadata as well. You can also use Auras, which is OCI registry, as storage, a tool for storing OCI artifacts on OCI repositories. So you will be able to do this. And for pulling, you can simply pull with plain HTTP. So Zot also supports storage and retrieval of Helm charts. So you should be able to Helm push the TGZ to the OCI Zot registry. And you can pull it as well with authentication. You need to provide those. So that's how simple and neat Zot is. It gives you a very effective, easy, lightweight mechanism for storing your OCI artifacts, completely OCI compliant for on-wire, and even when it is stored inside the registry, having native integrations of LDAP and all the authentication authorization mechanisms, which is there, a UI that you can use, a good search functionality, vulnerability scans. You can use cosign and notation for signing and verifying your images as well, which is pretty simple. So I think it provides you a very good all-in-all neat solution if you are looking for your private registries, or if you want to host your own registry for your own artifacts, prevent from rate limiting and stuff like that. So very interesting project, in my opinion. Zot and its adoption is, getting increased day by day because of the simplicity of the project and the neatness of the project, which is there. So yes, you can contribute to the project as well. So I'll put the project GitHub repository in the description. I'll also put the gist of the values.yaml file in the description of this particular video. Before ending the video, just make sure to like and subscribe to this particular YouTube channel, because that's what keeps me going. And also you can share it with your friends. Last thing, again, thank you to Cisco, Commodore, Sysdig, and Slim AI for helping me creating these videos. They are amazing organizations because they are helping the community, giving me time and helping me create these set of videos for you. So I hope you enjoyed Zot. Let me know in the comment section which registries you are using, or if you are researching on the image registries. Some of the features I would love to have with Zot is some mechanism, native integration with Docker. I know it's purely OCI compliant, but since Docker is massive ecosystem, so there was one GitHub issue as well that I saw, and multi-tenancy is another thing that I do not see any source of information. So that is something I would be interested to look at in the Zot project. So that's pretty much it for Zot. Thank you so much for watching, and see you in the next one.